Hello, my name is Matthew Vey, and I'm going to spend some time talking to you about improving database performance using quality tools from the perspective of SQL tuning. I think it's fair to say that database and SQL tuning is often the elephant in the room. Nobody wants to talk about it, let alone do it. Too many organizations just end up throwing money and hardware at poor performing databases rather than doing proper routine performance work. It is inefficient and it's a waste of money. For the purposes of this session, I will be looking at an Oracle database, and I will be using Embarcadero DB Optimizer to work through several common problems that should be very familiar to anyone who has spent much time working with SQL. It's not exactly a surprise that DBAs and developers spend less time than they should on performance work. It can be a very difficult, frustrating, and repetitive task for many reasons. For example, it is very common for changes to application SQL to come from external sources, third parties, other in-house teams, automatic software updates, etc. These changes are not always well documented or defined, which adds to the work required when trying to address any performance issues that occur as a result of a change. Additionally, the very nature of databases in SQL make performance tuning and troubleshooting very complex. No SQL or application runs in isolation. Any activity on the database can, and often will, impact any other activity. This makes it critically important to understand all of the activity on a database at any given time in order to effectively resolve performance problems. The best way to get the complete picture is to use a quality tool to capture interesting activity, dig into observed problems, resolve them, and then validate the resolutions. So here is Embarcadero DB Optimizer. It has many different features, but I will focus on specific uses of the tool in order to demonstrate how important good tooling is to managing performance and doing so both quickly and efficiently. I will be using the SQL load editor that you see here to simulate the example scenarios we will be looking at. The load editor is a lightweight tool intended to make it simple for users to run load against a database or to test queries. The second major feature we will be making use of is the profiler. This feature collects activity data from a database, runs certain calculations, and then presents all of the information graphically, a load chart on top with tables of interesting data below. The third feature of the tool we will be using is the SQL Tuner. This editor will allow us to investigate and measure ways to improve different pieces of SQL. This includes rewriting queries, performing index analyses, and even examining the shape of the query graphically, which can be especially powerful. Okay, now we're ready to create the 3 example scenarios. First, I'll connect to the data source that I have already registered in the tool, and start profiling by simply selecting the data source and clicking on the Start Profiling button. You can see the profile editor open, and we can also see that there is no data visible, which is expected as the database is currently idle. The next step is to simulate the example scenarios we will be looking at. I'll do this by opening a number of SQL load files and running them against the Oracle instance a few at a time, just like this. And now we can see the new load on the database start to appear in our profile editor, in the load chart above and in the tables below. Our 3 example scenarios will take some time to produce, so let's just fast forward through the boring parts. Now we'll run the first half of the SQL load for the second scenario example. We'll finish off the second example scenario with 2 more SQL load runs. Lastly, we run the SQL load for the third example scenario. Okay, we now have all of the example scenarios complete, and here we have our profiling session that captured all of the activity data from our Oracle instance while our load was running. Let's stop profiling and take a look at the profile editor. The top half of the profile editor contains the load chart, describing the activity that occurred on the database over the period of time that profiling was running. Beneath, you can see 3 tabs showing some summary data about SQL statements, wait events, and sessions. In addition, there are other tabs with more data on those 3 topics, and others, as well as detail tabs that will show up when we look at individual SQL statements later. In this session, we're looking at 3 examples with performance issues to resolve, and those examples are located on the load chart here, here, and here. The first example is an interesting one. If I use my mouse to select the first area, we can see that there are really only a couple of interesting queries being run. Why is this interesting, you ask? Well, in general, it's fairly straightforward to identify queries that are both long-running and appear to be taking up too many system resources. In this example, however, as I switch to the SQL tab, we have established, as part of our hypothetical example, that the first query is a pre-existing piece of application code that the DBA is familiar with and has already tuned. The query with 366 executions, however, is a brand new query the DBA has not encountered before, so it's the result of some change. A lot of DBAs would look at the average execution time of 51 milliseconds and move on. But that is the sort of behavior that can lead to badly running databases over time. It is just as important to tune fast queries that run often as it is to tune slow queries that run less frequently. So from here, we can right-click on the SQL statement and select Tune to open the query up in our tuning editor to do some analysis. In the interest of time, I have already prepared a tuning editor containing the example queries. So let's go take a look at the query and determine how well it is performing. Let's talk briefly about the tuning editor, just so that we understand all of the information being presented. We see that our first example is right here at the top, with a short list of the tables queried at the top level and some additional information. The total number of tables and views referenced in the query, the elapsed time for the query's execution, as well as the best improved time, but we'll get to that in a minute. We also show 31 cases and several distinctly colored counts of indexes, green, blue, and gray, each at a count of 2 for this query. As I said, this tuning session has been pre-prepared, so I have already generated the cases, run the detail analyses, and executed several of the cases. Let's talk about the cases quickly. A generated case is a generic term for one of the different ways the tool tries to alter the query in an attempt to improve performance. In general, the tool generates cases in 3 different ways: rewrites, transformations, and hints. If I expand the first example below, you can see some of the different cases. You can also see the explain plan cost for the cases, as well as some execution statistics for the cases that I have already executed. With that in mind, let's switch to the Analysis tab and look at our first example. You can see the full query text formatted on the top left. On the bottom, there are various tabs showing indexes, statistics, and other information. For this example, however, let's look at the diagram on the right. It is what we call the VST, the Visual SQL Tuning Diagram. DBAs are already familiar with looking at graphical explain plans, which help to understand existing execution paths and strategies. It is just as important to understand the relationships between objects in a query without relying on existing explain plans. A more thorough understanding of a query and its objects and schema is always beneficial when it comes to managing SQL and performance. Here, we can dig into the relationships of the objects in the query from the perspective of the query itself. We can look at row counts, both for objects and for joins. We can see that there is an exists subquery and dig down into that to see what is inside of that subquery. We can even see filter counts, describing how effectively restrictive the where clause is for the query. Views can also be expanded to see how the objects inside the view are related to the objects in the query that uses the view. Alright, so there's a lot of great information here, but there are no obvious irregularities shouting at us, So let's go back to the generated cases. As you can see here, one of our SQL rewrites has generated a case with a much lower explain plan cost. In addition, as I have already executed the original query and the case, we can see that the execution time went down dramatically, from 40 or so milliseconds down to around 10 milliseconds. So what is this rewrite? Let's look. Select the two cases we want to compare, in this case the original query and the new rewritten case. Right-click and Compare Selected. The exists and not exist filters have been rewritten as equivalent in and not in filters. The query returns the exact same result set, but does so much more efficiently in this case, due to Oracle's own optimizations. Now the DBA has an improved query that executes 4 times as fast that they can discuss with whoever wrote the original. For me, what makes this scenario interesting is that it's a great example of how easy it is to use a good tool to quickly make small changes for high returns. Too many DBAs perform this type of work manually, which can be very time-consuming. I would be willing to wager that almost every database and almost every organization could see significant performance improvements with just a little effort and the right tools. Alright, so we've looked at the first example where we took an often run quick query and made it even faster. Now let's move on to our second example. We will select the second area of the chart, and here we observe another small handful of queries. Perhaps in this example, the DBA is concerned that these few executions are consuming too much CPU and may impact other application load that will soon be deployed. In that case, we should definitely look at the query with the highest percentage of activity. 30 executions with a 20-second average execution time. Again, to save time, the tuning session already contains results for the second example. Let's go take a look. This time, let's go look at the generated cases first, since they're right here anyway. Okay, so immediately we can see something interesting. There's a yellow tinted row reading missing a valid join criterion, nested query and where clause, and this is a transformation case. We can also see that the explain plan cost for this transformation case is significantly lower, as is the execution time, going down from 4 seconds to half a second. That's great. Instant improvement. And while getting that kind of performance improvement so quickly is great, it's just as important to understand what the change is and why it is so significant. Let's move to the Analysis tab and take a look at our second example there. Right away, we see what that missing valid join criterion message meant. The investment table is not joined to any other object in the query. This is sadly a very common problem. The sheer amount of SQL deployed on databases these days far exceeds the resources of most DBA and developer teams to adequately test and tune. Bad SQL slips through the cracks sometimes. So, we know the transformation fixed the problem, so let's see what that looks like here by looking at the analysis for the transformation case. That looks much better, and you can see the new join, based on existing foreign keys, in the SQL on the left. Back on the Generated Cases tab, we are reminded that in addition to the missing join, the case also changed a nested query. Let's just compare the SQL of the original and the new case to see what that change was. Here we see both the new join and the transformation of what was a nested query and a filtering clause to what is essentially an inline view that Oracle can better optimize during execution. Problem solved. I like this example because it shows how multiple problems can be addressed simultaneously with the right tools. Developers writing code take this sort of ability for granted, as quality tools have been around for years to help them accomplish similar tasks. The ability to write, optimize, and manage SQL as easily as code, and just as quickly, is just as important. Also, if we switch back briefly to the profile session, you can actually see the transformed query run as often as the original in that small bubble of activity on the right side of the selection. In fact, you can see that the profiler captured 0 executions. That's simply because the modified query ran too fast to properly observe. Our third example fits into the cataclysmic category. Every DBA in the world has probably experienced the sinking sensation when new application SQL is deployed and their carefully nurtured database grinds to a shuddering halt. That's exactly what we see here. A database that typically experiences a fair amount of load is suddenly overwhelmed with what we can see are a couple dozen sessions stuck in contention waits. That's nobody's idea of a good time. If we take a look at the SQL tab, we can see that some pre-existing application code, the inserts for this hypothetical example, are suddenly taking almost 45 seconds to complete. Under other circumstances, a DBA might be inclined to spend some time looking into the insert statements to see what's going on, but we already have more information and we can make more informed decisions. First, we have already observed that the insert executions are stuck in a contention wait, which means that another session is holding resources they need. Second, we can see another SQL statement, a delete, is taking just over 3 minutes to execute. From the chart, we can also see that the waiting sessions appear to be waiting for approximately 3 minutes. That's an interesting coincidence, isn't it? So we have seen a problem illustrated graphically and have been shown information about all of the interacting sessions in SQL. We have been able to immediately see relationships between SQL, sessions, waits, and we've been able to define an avenue investigation that looks promising. That's a lot of value for just a few seconds of quick inspection. I think we all know what comes next. Let's tune the delete statement and see what's happening. Well, there it is again, missing joins. We'll compare the transformation case with the original case, and we can see that there were 2 joins missing that have been added as part of the transformation case. We also see how quickly it executes when the joins are correctly added. Cataclysm averted. Okay, I think this third example might be the best of the 3. Not because we solved a problem that had brought an imaginary database down to its knees, but because we were able to see so much information about the problem almost instantly. Knowledge is critical, and being presented with so much performance information and statistics is the sort of thing that should make any DBA's day. So many DBAs and developers still perform these tasks manually. It's actually a little depressing when I think about how many wasted hours are spent manually gathering data that should be gathered automatically and analyzed by a quality tool. I don't think anybody needs to be reminded that wasted hours equals wasted dollars. Let's summarize a bit here. We've gone through 3 separate example problems and solved them. Admittedly, the problems weren't particularly complex, but that wasn't the point. The goal was to illustrate what should be the low costs and high returns on regular performance work. Database machines and licenses aren't particularly cheap. Unexpected downtimes are even more expensive. Regular performance tuning is important work that rarely gets prioritized and ends up costing organizations a lot more than it should. In closing, I have one final comment. Performance work and SQL tuning in general is often perceived as terrifying, intimidating, or monotonous, depending on who you're talking to. It shouldn't. With a little bit of knowledge, some patience, and the right tools, it can and should simply be part of the daily routine of any DBA or developer working with SQL. Thanks for watching.
There was a first question from Michael, which you answered. What is the memory and CPU overhead for running DB Optimizer, and how many additional connections are being used or generated?
Yeah, I answered that one. In general, the overhead for using DB Optimizer against a target database when profiling is under 5% of the overall database activity. So as a percentage of the database machine's resources. And on Oracle specifically, it's under 2%. So we're very lightweight.
And I've often wondered, do you have to do anything special after you install DB Optimizer? It has to have, what, administrative rights or system DBA rights? Maybe you've already covered that and I missed it.
To install, obviously, you should need to be an admin on the local machine. But to profile a data source, the rights required vary slightly by platform and version. For example, on SQL Server, you must have been granted the select catalog role or have similar set of permissions. On Oracle, you need almost no permissions whatsoever except for tuning, in which case you need certain permissions so that we can collect information like histograms, outlines on Oracle 10, some other information. So it varies slightly. It's all available in the application documentation.
Okay. Sebastian asks, are the algorithms DB Optimizer uses to generate cases, are they proprietary, DB specific, any room for customization?
Oh, okay. So let me just, I'll type while I'm talking. So the All right, so the easiest way to answer this one is this way. The queries we run are not proprietary. There are a number of similar tools. We all do things in sort of the same way sometimes. Internally, the way we analyze the data that we display, we do that in a way such that, well, that part of it is proprietary. Yeah. But the queries we use and all of our algorithms vary by platform and version like everything else. Oracle 10 is different than Oracle 9. SQL Server 2005 is different than 2008. Sybase ASE 12.5.4 is different than 15.02, etc. So we have sets of code specific to each of those versions. And there's currently no way to customize any of the queries that we run. And there's no real need to at this point.
What is the shortest time slice that you can measure?
That's an excellent question. So we actually spent many months looking into this ourselves. So when you're capturing this sort of data from a data source, from a database, we'll stick with Oracle as that's the example I presented. There's a trade-off. You want to get as much good data as you can, but you don't want to cause a performance problem of your own. You want to be the invisible hand collecting data that doesn't interfere with the database activity itself. So what we found seemed to work best was 1 second, approximately. The idea being that if there are queries that run faster than 1 second, it is possible that we'll miss that query execution. It may start, execute, and complete between our collections of data. But that's okay, because a query like that probably isn't interesting, and we don't need to look at it. However, if that query is being run very often and should be interesting, well, in that case, we will notice it because not all of those often run executions, they're not all going to fall between our collections, and so we will collect data on it. So we found that 1 second for our primary collection seemed to work the best. And in the UI, in the profiling chart, we roll that data up into 5-second slices. So as to be useful for the user to look at. I think that answered the question.
Okay, great. With JDBC, could you also use or measure MySQL?
MySQL isn't a supported platform right now. Something we might do in the future, but not so far.
Okay, so the platforms, I think there's 4, right?
Yep. Oracle, SQL Server, Sybase ASE, and DB2 for LUW.
Okay. No, I love the profiling. We use profiling, of course, in our code. So I'll ask this question and see if others might chime in with other things. When I think about profiling code in my world, or good design before I get to development, I think about running audits and metrics and profiling as early as possible in the development cycle, as opposed to thinking about, oh my gosh, I've got some terrible problem. It's in deployment, production. I got to profile and find out what's going on. What do you advise database designers, developers to do before they have to worry that the DBA is trying to track down a problem?
Well, in my opinion, I think the best way to avoid those sorts of problems is to have optimization and SQL tuning and profiling be part of your daily work. It should be part of your process. Just as often as you write code, you should be profiling that SQL. You should be making sure that your SQL's tuned. You should be, making sure that the load on your database is appropriate to the application load that's going on there and maybe what's coming soon. The more information you have, the better armed you are against any potential problem. And it can be trivial and easy to get this information, so it just seems crazy not to.
So I guess one thing would to say, as soon as you have a database, since DB Optimizer can generate these test cases, right?
Yep.
You don't even have code. You don't have anything else done. You can start profiling right then.
Yep.
And it's not on the final hardware necessarily if you don't have that yet. Maybe that's being ordered or something.
Sure. It's. I mean, I'm sure a good percentage. I mean, I know a large percentage of our user base doesn't use DBO on their production databases because there's just too much risk and there's too much security involved. But they use it in their UAT environments and their development environments, and just to make sure that that everything that they do deploy to production works well.
I should have said pre-production test. Maybe would be the right way.
Sure.
Do you know of any customers who do, when they have a problem on a one-of-a-kind hardware configuration, do you think they ever use DB Optimizer and do some probing? Or
for sure, so it varies slightly by platform, but again, I'll speak mostly about Oracle. Oracle has a number of, if you remember the profiling chart where you see all the pretty colors and lines and bars, Oracle records lots of wait event information for sessions that are blocked by something, and they have many of these waits that are operating system and hardware specific. So that information is totally available, and it can vary by machine. So yeah, that's always worth looking at.
Maybe that's one of the pictures I put up on the screen.
Sure. Yeah. So in the events area in the center there at the bottom, some of not in this particular example, but there are weights that are OS and hardware specific that will show up, and that will indicate if that can indicate, not will, but can indicate if a particular hardware configuration or environmental concern is causing a problem on your database.
Okay. Is there any magic? Can it automatically update the SQL statements, or you have, once you tune in, right mouse click saying fix this?
We actually very temporarily, very briefly, for the course of 3 months, had that functionality in there for certain cases, and then we had to quickly remove it because it's just too dangerous.
Yeah, it's dangerous.
Yeah.
I know.
Yeah.
You'll want to go back and take those statements and do some more testing. And
yeah, it's never a good idea to instantly deploy.
But it generates the scripts, right? So you can take them and
oh, yep, for sure.
Them to somebody and so on. Okay.